Alright, you are welcome back to Introductory Mathematical Analysis A, and we are still in chapter 13, and in chapter 13 now we are going to go into 13.6. We are going to go into 13.6. Okay, so in 13.6, we are dealing with applied maxima and minima. That is 13.6. We are dealing with applied maxima and minima. Okay, so everything we have learned in the previous one, 13.1, 13.2, 13.3, 13.4, we're going to be, and 13.5, we're going to be making use of them in this applied one. Okay, let's go. Now for this example, we have this example now. A manufacturer plans to fence a 10,800 feet square rectangular storage area adjacent to a building by using the building as one side of the enclosed area. The fence parallel to the building faces a highway and costs $3 per foot installed, whereas the fencing for the other two costs $2 per foot installed. Find the amount of each type of fence so that the total cost of the fence will be minimum. So we are finding relative minimum. Take note of that. And then what is the minimum cost? Okay, we are finding relative minimum. All right, so this is a picture of what we are talking about. Now we have want to fence a building, to fence an area, and this other side is already facing a building or on a building, and there's no need to fence this other side. Now we have this side to fence. This side we call X. That is the one facing the highway. We have this one, the other two sides. Okay, so the challenge with this type of question is that you must first bring out the equation, the mathematics, the equation you need to derive. Okay, so you need the equation first to derive, and then you follow either the first derivative test way or the second derivative test way, and then you solve for it. Okay, now the first thing is that we need an equation, and you can see this is a square because it's a rectangular. No, it's a rectangle. Because it's a rectangular shape, we can use the perimeter of a rectangle. Okay, so the perimeter of a rectangle, but I will call this time around cos, because we need to include the cos later. C equals to, we will have x plus 2y. Okay, I'm just using y plus x plus y again to give us this. But don't forget that the side has a cost attached. So $3 per foot installed, the one facing the highway. So that means this side facing the highway is 3. So I need to multiply this x by 3 so that I can have the cost. Now the other two sides is 2. So that shows I need to multiply this by 2. I need to multiply that by 2. So now I'm going to be having 3x plus 4y. Okay, that is the cost. Okay, that is fine. But if you look at this cost, C equals to 3x plus 4y, we are now having C in terms of x and y. In terms of x and y, that is two variables. And you have not been taught how to go about deriving two variables. So that shows we need to now make this into one variable, into x alone or into y alone. All right. So in order to do so, let's read the question again. A manufacturer plans to fence this rectangular storage area. So the area should be equals to this. So that means the area of a rectangle is length times breadth. So that means the length and the breadth should be equals to 10,800. Okay, that is the area. So we can now make x the subject or y the subject and then put it there. So let's make y the subject here. So now I'm going to have y equals to over x. Okay, now I can bring that into this my equation. So anywhere I see y, I put this so that I can make it a function of just one variable, 3x plus 4 10 on 800 over x. Okay, that's fine. Then this will give us 3x plus this is 0 0 2 3 1. Okay, over x. Okay, that is it. That is it. So this is our c now. Okay, which is our cost function. This c cost function is now giving us this. So what do we do now? We have the function now already. We have the function already. So what do we do? In our first derivative test or second derivative test, we need to find the derivative first. Finding derivative test. So I find the derivative of this. What is the derivative of this? Is 3 plus this one can be written as 13200 x minus 1 can be written as that. Okay, so if I derive it with that one, so we have minus 13200 x minus 2. Okay, all right. So that will now be giving me 3 minus 132 00. Oh no, not 32. This is supposed to be 4002 remain 334. That's supposed to be 4. Sorry, that's supposed to be 4. That's supposed to be 4. Yeah. This is supposed to be 4. This is supposed to be 4. This is supposed to be 4. Okay, let's go. So now we have this also. This is supposed to be 4 all over s square. Okay, that is the derivative. Now the next thing is to equate the derivative to 0, but I can write this as a single fraction like this. Okay, that will be 3s squared minus 43200. Okay, I can write it as a single fraction like this. So equate the derivative to 0, equate the derivative to 0. Okay, if I equate the derivative to 0, I'll be getting 3s squared minus 43200 all over s squared equals to 0. Alright, if I cross multiply on that, I will get 3s squared minus 43200 equals to 0. Then 3s squared equals to 43200. Okay, so if then s squared will now be this divided by 3. That is 1, that is 4, that's another 4, 0, 0. Okay, so now our x equals to plus or minus 1400. Okay, which will be giving us then that s equals to 120. But don't forget that now we are dealing with an application. So whenever we are dealing with application, a real life situation, the value of our x and y will not be negative, will not take negative. So we only take the positive part of our x and y. So it will not be negative. Okay, so now we have this to be, that is, yes, x equals to 120. Okay, x equals to 120. So the next thing to do is to test if this to write our critical values first. To write our critical value first. This is our x, so let's go into this first derivative and check where will the first derivative not exist. Of course, when x equals to 0, the derivative will not exist. Okay, so that is part of our critical value. So we put that as part of our critical value. So our critical values are x equals to 0 and 120. Okay, the next thing is either we use the first derivative test or the second derivative test to get which one is minimum, which one is maximum, or which one will give us relative minimum, which one will give us relative maximum. So you can either use the first derivative test, or the second derivative test. You can either use the first derivative test or the second derivative test. Okay, let me go with the second derivative test. I will go with the second. So in order to use the second derivative test, that shows you need to derive this one the second time. Derive this the second time. So when you want to derive, it's better to use this one. It's better to use this one to derive. Okay, I want to derive this the second time. Okay, this one can be written again this way. It's still the same thing as 3 minus 43200 x minus 2. Okay, so you derive it the second time. So let's derive that the second time. We are using the second derivative test now. So don't forget the first one, the first derivative is 3 minus 43200 x minus 2. Okay, now I want to derive this the second time. Deriving this will give us 0, this will give us plus 2 now, multiplied by 43200 x minus 3. Okay, that is the derivative the second time. Okay, so now this will now give us 0.0468. Okay, all over x raised to power 3. Okay, that is derivative the second time. Now, in this derivative the second time, we need to now put of 0 and also we get of 120. Okay, and see which one is giving us minimum or maximum. Okay, let's go to another page. Okay, so we have that the second derivative is 86400 over x raised to power 3. Okay, now we want to find this of 0. It is 6400 over 0. You see, this one will give us undefined. This one will give us undefined. So 0 will not give us the value we want, so we don't count that one. So let's go to C prime prime of 120. C prime prime of 120 will be this 00 over 120 raised to power 3. Okay, you can get what is that value, but what I am interested in is that this is positive. That means this is greater than 0. Because this is greater than 0, from the second derivative test, second derivative test, 120 x equals to 120 is a relative minimum. Okay, is a relative minimum. Okay, so that's what we want to get. We want to get that this is a relative minimum. So the point x equals to 120 gives a relative minimum. Okay, so we can go further now and get the minimum cost. If this gives a maximum, then we cannot proceed because we are looking for minimum and not maximum. Okay, so we cannot proceed. Don't forget the question. Let me go back to the question and you will see what I'm talking about. We need where the total cost will be minimum. Okay, and then we are looking for minimum cost. Okay, so where it will be minimum is x equals to 120 will give us relative minimum. Then let's now find the minimum cost. To find the minimum cost, you use the function c of x, the function we derived before, which is c of x. That is what we use in order to find the, so this function is what to use. So you put the value of your x in this function, okay, that means the function again, I write the function again, 3x plus 43200 all over x. I hope I'm correct. Let's check back. Yes, that is it, 43200 all over x. Okay, all right, so that is it. Then we put 120 there, so c of 120 will give us 3 of 120 plus 43200 of 120. Okay, try to find that. When you find that, the answer should give you 720. Okay, that is the cost in dollar, of course. That is the cost that we take us. You see now, so we are the first thing to do whenever you are given a word problem like this, you have to find out the function first. The function or the equation you need to use, then you derive it, then you equate the derivative to 0, and then you get your value of x, and then you get the critical value by checking up again on the derivative to know if there's any point it will not exist. Okay, if there's any point it will not exist, okay, then that will be part of the critical value. Okay, don't forget, whenever we are dealing with application problem, we are only dealing with x to be positive and y to be positive. Okay, all right, so, and then you derive. You can now use either the first derivative test or the second derivative test to find your relative maximum or your relative minimum, depending on what you are looking for. I hope you understand. Please ensure you understand. All right, that is all what we have done. That is all what we have done. Okay. Okay, another problem, another example. A manufacturer total cost function is given by this. That is the total cost function, where C is the total cost of producing Q units. At what level of output will average cost per unit be a minimum? Average cost per unit be a minimum. What is the minimum? Or what is the minimum value? What is the minimum value? Okay, what is the minimum value? All right, now again, they give us a cost function, but they ask us to find the average cost, the minimum of the average cost. Please take note. So average cost, let me call average cost this one. Okay, average cost, I call average cost this. Okay, average cost is simply total cost over Q. You divide the total cost by Q to get the average cost. Okay, so that means this will give us, this now give us Q over 4 plus 3 plus 400 over Q. Okay, that is the average cost. Now this is the function we need to derive, not this one, not this one. This is the function to derive. This is the function after your derivative to equate to 0, and like that and like that. Okay, so let's start with deriving this one first. So average cost, I'm deriving average cost with respect to Q. Okay, this will give me 1 over 4, this will give me 0, and this will give me minus 400 q minus 2. Okay, all right. Please take note of that. Now, what do? We need to equate this to 0. Equate it to 0. Equate it to 0. Yeah. So we equate that to 0. So equate of q to 0. So that means we are going to be getting, this one can be written this way, 1 over 4 minus 400 over q square. Okay, I can also write it as a single fraction, q square multiplied by 4, okay? So here is q square minus, this is 4, this is 1600. Okay, all right? So, all right. Yeah, so we have this. So that is what we're equating to 0. So q square minus 1600 over 4q square equals to 0. If you cross multiply, then you are going to get q square minus 1600 equals to 0. Okay, so that means q square equals to 1600. Then q equals to root of, again we are taking the positive side, don't forget, because we are dealing with a real world problem. We are dealing with cost function, so we can't have negative there. Alright, so we are going to have q equals to this. So we need to know if this is minimum or maximum. What today has us to find is the minimum. You see, so we need to test if this is minimum or maximum. You can again, okay, before then again, this is q. We need to find our critical values. Okay, to get our critical value complete, go again and check the first derivative. Where will this first derivative not exist? Where will it not exist? The first derivative will not exist when q equals to 0. Okay, the first derivative will not exist when q equals to 0. So that is part of the critical value. So now we have critical value to be q equals to 0 and 40. Okay, that's our critical value. All right, so now we need to check which one is minimum. Then by deriving again, let's use the second derivative test. So we can either use the first derivative test, or you use the second derivative test to know which one is minimum. To test for relative minimum or relative maximum, you need to use either the first derivative test or the second derivative test. Okay, let's go with the second derivative test. Using second derivative test. Okay, that what we need to do is to derive this the second time. Yeah, derive this the second time. Derive that the second time. So we have our first derivative of that, which is what is that one now? Our c prime. Okay, our c first derivative is given as 1 over 4 minus 400 over q square. I think so. Let's check again. Q square. Yeah, q square. All right. So that is my first derivative. Now I need to find the second derivative. This is 0. Then this will become 800 q minus 3. Okay, that's fine. Which is 800 over q3. Okay, that is the second derivative. Please know how to derive very well. You must know how to derive very well. Now, I need to now put the critical values into this second derivative. Of 0, obviously, we cannot have that one. That will be undefined. We cannot have that of 0. Okay, now let's now find for that of 40. 800 over 40. Okay, that will give us 20. All what we are looking for is that it's greater than 0. Okay, it's greater than 0, which gives is greater than 0. That is Q equals to 40 gives a relative minimum. A relative minimum. Again, if this gives a relative maximum, we cannot proceed again because what we are looking for is relative minimum, is minimum. So we can just conclude that there's no minimum in this average cost if it gives a maximum. But now it gives a minimum, so Q equals to 40 is a relative minimum. Now we need to put that into the function. Let's look at our average function again. This is our average function, Q over 4 plus 3 plus 400 over Q. That is our average function. Then we put Q equals to 40 there to get our value. So our average cost function is Q over 4 plus 3 plus 400 over Q. Okay, now we need to put the value of Q there. So we have of 40 will now become 40 over Q over 40 over 4 plus 3 plus 400 over 40. Okay, do the calculation. If you do the calculation, you should be getting something like 23. Yeah, 23. Okay, so that is the minimum value. Okay, the minimum cost. That is the minimum cost. All right, please ensure that you understand how we did all that. Please ensure you understand. Thank you.